Hi, everybody, and welcome to my masterclass, Making Science Purposeful, Practical STEM Integration in the Middle School Science Classrooms. So we will be looking at STEM education as a topic today and how we can make this purposeful in our science classrooms. So I'm just going to give some of you some time to log on. And if you can, just go into the chat and type there what subject or grade level you teach and where you are connecting from. It will be lovely to know. I can already see Doreen is here. Hi, Doreen. Welcome.
Hello, Nastassia.
We will just give a couple of minutes, seconds actually, for people to join. Okay, so my name is Nastassia Enslin, and I am currently a middle school science teacher. I'm also the head of department and a sustainability coordinator in an American school in Abu Dhabi. And I have degrees in psychology, social sciences, criminology, medical sciences, as well as education. And I received the Teacher of the Year award in the UAE in 2018. That is where I am currently based. I have been teaching in the UAE for almost 10 years now. And I was also part of the Mars Mission Ambassador Program. I was fortunate enough to be an Expo sustainability volunteer, and I most recently represented my school by presenting at the STEM MENA conference. So everything that I do, all my lesson plans, all my sustainability projects are all filled with coffee and curiosity, and that is usually how I also plan my lessons. And I'm very excited to share this session with all of you today. So at the end of this session, you should be able to identify opportunities on how you can integrate real-world STEM applications into middle school lessons, how you can apply a practical framework to connect inquiry-based learning with critical thinking and collaboration skills. We are going to try and structure lessons to be purposeful, engaging, and relevant to students' lives. And then lastly, you'll be able to design simple hands-on investigations using accessible classroom materials. And if there is nothing that you remember at the end of this session, if you can just remember these three key takeaways: STEM integration enhances curiosity and problem solving across all topics. Meaningful learning happens when lessons are connected to real-world issues. And we want this to be purposeful, practical, and useful. So lessons doesn't necessarily require more resources, just intentional design. So we've all heard this. Students ask, why are we learning this? Will we use this? Am I ever going to need this again? And this is why we are here. We want to make learning more meaningful, and we want to be able to connect this to their real world scenarios so that they can make meaningful connections in the classrooms and can see how this can benefit them moving forward. So if you are able to, I want you to just scan this QR code. The link will also be put in the chat for you. And it is going to take us to Mentimeter. And in one word, I want you to just write down, how do your students feel about STEM? Do they know what it is? Have they used it before? Do they know that it is an inquiry-based kind of teaching and based kind of learning? Just go into Mentimeter and quickly write down one word. What do your students feel about STEM? And I will look at your responses on this screen. Okay, so I can already see some participation, and I can see some of you said that they are excited about it, which is wonderful. And I can see someone else said here that they are intrigued. So that is also a great way to describe how students see STEM. Some of you said project-based learning, exploration with fun. Um, Someone said the chat is disabled. I'm sorry, we will get someone to look at that for you. Um, yeah, so someone else also said that they are curious about it and they're looking forward to hands-on lessons. This is wonderful. So, what is STEM? When we look at the acronym, we can see that it says science, technology, engineering, and math, but we will be diving a little bit deeper into this today. So these disciplines are increasingly emphasized within the education system to get students interested in higher education and in careers that involve STEM skills. So again, we said it is science, technology, engineering, and math, but we also want to add art in there because we want to develop that creativity that is needed for science and STEM kind of careers that students can get involved in. So here are some pictures of what STEM looks like in real life. So when someone builds a bridge, that is a STEM career. When someone does web design or astronomy or environmental sciences, game development, these are all careers that we are currently preparing our students for. And they will also be careers that we don't even know about yet. So we need to make sure to equip them in order to be able to go into a workforce of STEM careers that need these skills, but also careers that are not known to us yet. So when we apply this in a middle school lesson, we can look at it as engineering a solution to a local problem. So this is all things that I have done with my students. And when we give them an engineering solution to a local problem, we want them to think of a design solution and use real world data. So we took our students to Masdar City, which is a sustainable city in Abu Dhabi. It's more of a suburb in Abu Dhabi. And they investigated real environmental issues within the rest of Abu Dhabi. And they realized that we have a heat island problem. And they decided to go to Masdar City on a field trip and try and see how they are reducing the heat islands in that area. So they used local temperature data, satellite images, and they also did this around their own school and their own environment. So through this, they practiced engineering design. They created a model that they tested and they revised it to see how they can reduce it. And they decided to reduce this through solar energy. And this is what Masdar City does as well. Another way that you can apply this to kind of assist your students for real world kind of jobs that's coming is through sustainable materials and chemical property investigations. And for this, we took our students to SeaWorld. And during one of our matter and chemistry units, they compared biodegradable materials such as cornstarch, plastics, paper, and mushroom packaging to the more traditional materials. And this mirrors what material scientists actually do during sustainability research. So they work with criteria and their constraints. They were given a cost, they were given a budget and durability and a time constraint, and they were practicing real testing methods. So in SeaWorld, they had an opportunity to do this where the students could see the impact that plastic has on the marine life. And they wanted to try and create an awareness for this. So after they did this, they created an awareness campaign in school, and students were a bit more considerate when they went to beaches. They also participated in beach cleanups. So we have identified opportunities to integrate real-world STEM applications into middle school lessons. So we have achieved our first objective. So what are the benefits of STEM education? Critical thinking, creativity, confidence, collaboration, teamwork, curiosity, innovation. And when we look at the first one, which is critical thinking, students compare two conflicting sets of data and they question which method or measurement or variable have caused the differences before drawing conclusions. So here is an example of how students created data on how sound travels through a solid, a liquid, and a gas. And after this activity, they then went and they compared their data with that of friends and peers in the classroom. So when we want them to also be creative, we give them a design challenge. And we ask students to sketch an unconventional prototype, and they have to use recycled materials and sand layers to build a low-cost water filter. So this was the beginning stage, the design stage, and later on students went on to actually build this, and they were so impressed to see that this is such a low-cost method and that they can filter water by just taking materials that they have around them and that's available to them. STEM education also builds confidence. So students share their designs, their ideas, and they explain their reasoning through creating a CER, which is a claim, evidence, and reasoning discussion. And even if they are unsure, they trust the process and their abilities, because when we do STEM activities, we want it to be collaborative a lot of times, and we include other people who have strengths other than the students have, so they share their different strengths, and that way they build their confidence. And this brings us to collaboration, as I just mentioned. So here a group was divided in separate roles during a lab activity where one student measured, one recorded the data, one checked the procedure steps, and one ensured that there was safety measurements taken throughout the entire lab activity. So they were also able to communicate clearly, and they had to complete the investigation as a collaborative team. And STEM education tries and ignite curiosity. So a student might notice that plants in a lab are growing differently, and they might ask, why is this one taller, even though they may have gotten the same light? So there's a quick way to investigate this, and STEM isn't just hands-on activities, we also use simulations, and this is a gizmo simulation where students can put the same seeds in 3 different pots and give them different kinds of sunlight just to test how the sunlight affects them. And they will be given different sets of data. So Gizmos is an amazing platform for STEM education and to test curiosity within students. So we want our students to become innovators through STEM education. We want them to think like people who are going to create new ideas and create ideas to solve problems. So in this activity, students will take an existing problem, and we used something simple, get the marble in the cup. And they had to modify it using the recyclable materials that they had available in the classroom. So we had many of these different types, but they all did the same job. So I will play the video for you.
Okay, I think we're just gonna do this as it is. Yeah!
Students were very excited to share their Rube Goldberg machines with other peers, with my colleagues, with their teachers, and they were really excited to go through the process to see what worked, go back to their prototype, go change it, go see what material would fit in that specific area better than the ones that they have picked. So in the chat, I just want you guys to quickly type, one thing from your daily routine that you think connects to STEM, even if it's not obvious. Just one thing you might think connects to STEM education, even though it may not seem obvious. And this way, we are already collaborating, because whatever you are typing in the chat, other teachers and educators and administrators can see what you are already doing. Okay, feel free to continue typing in the chat. So I mentioned earlier that we need STEM education to try and prepare our students for future jobs that they will need these skills for, and jobs that don't necessarily even exist yet. So why STEM education shapes the future?
Science, technology, engineering, and math, together they form the backbone of innovation. STEM education is more than a collection of subjects. It's a way of thinking, solving problems, and building the future we want to live in. From early classrooms to advanced research labs, STEM learning empowers students with the tools to understand the world and change it. It encourages curiosity, nurtures creativity, and teaches resilience through experimentation and failure. Why does STEM matter so much today? Because the world is changing faster than ever. Climate change, clean energy, pandemics, artificial intelligence, these are challenges that demand critical thinkers and innovators. STEM education equips students to face them head-on. In classrooms that embrace STEM, students learn how to ask better questions. They learn how to explore, test, and discover. They stop memorizing facts and start building solutions. That shift transforms students from passive learners into active creators. STEM isn't just for scientists or engineers. It shapes skills that apply across every field: analytical thinking, communication, teamwork, and adaptability. These are the skills employers value most in the 21st century. And they're essential for preparing the next generation of leaders, no matter the career path. We also know that equity in STEM matters. Too many students, especially girls, students of color, and those in underserved communities face barriers to STEM opportunities. That's why inclusive STEM education is critical. When every student has a seat at the table, we all benefit from diverse perspectives and untapped talent. Programs that spark interest early, robotics clubs, coding camps, makerspaces, can change a student's trajectory. They show that STEM can be exciting, collaborative, and relevant to real life. And when students see role models who look like them succeeding in STEM, it fuels belief in what's possible. Governments and educators around the world are recognizing this. Investments in STEM education are increasing, and policies are shifting to support hands-on, interdisciplinary learning. It's not just about textbooks anymore. It's about real-world impact. The future is being written right now by students who are learning to code, build, design, and question. They're the ones who will develop cleaner energy, smarter technology, and more equitable healthcare. They'll drive innovation in ways we can't yet imagine. If we want a future that's sustainable, equitable, and full of opportunity, then we need to invest in STEM education today. Not just in funding, but in mentorship, access, and inspiration. Because when we give students the tools to think critically and solve creatively, we're not just preparing them for jobs, we're preparing them to shape the world. And that's why STEM education isn't optional. It's essential. Science, technology, engineering, and math.
So just to put everything that the video just discussed in a nutshell, is that STEM is not a collection of separate subjects. It is supposed to be an interconnected way of thinking, and it emphasizes problem solving, creativity, and applying that knowledge to real-world challenges. Something I also want to add is that STEM education links very closely to sustainability and ways to be more sustainable. When we are thinking of the SDGs, which are the Sustainable Developmental Goals, we want to solve a problem, and those problems are solved through STEM education. So what does this mean? It doesn't mean that STEM is just set for science, technology, engineering, math, or art subjects. There are STEM opportunities in subjects that are considered non-STEM subjects, such as history, physical education, and English, to just name a few. So STEM in non-STEM subjects, history and social sciences. So the activity students had was they needed to create a data investigation timeline based on George Washington, and they built a timeline of his life, and they analyzed related data such as the troop numbers or the population changes or the distance that they traveled. And they used simple math and graphs to understand how these resources and logistics shaped key historical decisions that they are currently learning about. And the STEM connection there was using data analysis and modeling that to interpret historical events and the impact it currently has on our lives today. Physical education. So students did an activity where they looked at their heart rate and connected that with body systems in biology. So it was a cross-curricular activity, and they measured their heart rate before running and then after, while doing different forms of exercise, bouncing the ball, running from one side to the next. And they created a graph with their data where they compared patterns and explained how the cardiovascular and muscular system responded to this physical activity. So they collected data, they analyzed patterns, they understood their biology through real-life measurements. And then in English and literature, students were learning about a long walk to water, and they needed to create a water well infographic. And they researched how water wells were built and what factors affected access to clean water. And they created an infographic using the real data, such as groundwater depth, cost, or well success related to the information in the book, which was in Sudan. And the STEM connection here was they did research, data interpretation, visual communication to explain real-world engineering solutions. They were later asked, because we don't really use wells in cities anymore, how would we be able to interpret what happened during that time and connect it with what people are going through currently that doesn't have water? They also linked this activity to the SDG number 6 that you can see at the bottom of one of their posters, which is a sustainable developmental goal. So in other words, they were looking for a solution using STEM to kind of support their findings. So now we kind of know what STEM is, and we know that we can apply this in more than one subject. But if we are going to do this, we need to also redefine STEM to fit in with our 21st century skills. So we want to make sure that whatever we do in terms of STEM is purposeful. And this means that we are connecting our lessons to real life problems and things that students actually care about. We want to make sure that it is practical, and it means that it is low prep for teachers and accessible using materials that we already have. And we also want to make sure that it is useful and it can transfer skills like communication, data, literacy, and teamwork. So what does this mean? We want STEM to be purposeful, practical, and useful. So when it's purposeful, it is linked to real-world issues. For example, clean water access. When it is practical, We use available resources. So students can measure water in their community, water usage within their schools. And when it's useful, they build transferable skills. They can create an action plan or a campaign to reduce water wastage. So STEAM is so important because it ignites the imagination and sets the soul on fire. It allows students to create endless ideas, and it allows students to explore the world through their fingertips. The possibilities that it provides for learning are limitless. This is from a grade 5 teacher, seeing how STEM has impacted her teaching and learning through giving her students opportunities to express themselves and explore their world around them. So let's see how we can apply STEM in unexpected places. And I want you to put on your teacher hat for this activity. I want you to scan this QR code. It's going to take you to a collaborative Canva page. And I want you to imagine that your school playground floods every single time it rains. Now, if you live in the UAE, that is a very to buy any new resources. So how can you design a low-cost STEM solution to address this issue? So you can scan the QR code. Like I said, it will take you to a collaborative Canva page. And you can respond on there. I will look at some of your responses. Someone said you can use a garden fork to punch holes every 30 to 40 centimeters. That's an interesting solution, yes. Someone else here said a flex hose or a PVC pipe to discharge water away from the playground. That is a great solution. Try and take the water away from where it floods. So you will see there are some responses on the virtual sticky notes already. Just pick a sticky note that is open and you can put your response there. Someone said, please ask the gardener for help. Build a bridge to keep the children on high ground. That could happen, yes. Okay, I'm just going to give another minute or so for you to add your solutions. I can see that we are all active on this page. Someone said drainage holes. A small engine that absorbs water, having a sensor showing the water level so that when it reaches a specific level, it starts pumping out the water to the sewage area. All right. I can see some people typing. So this is a typical idea of a STEM activity you can also give your students. They can come up with solutions on how they can overcome this challenge on their own playgrounds. And you can use something as simple as this Canva collaborative space for them to work on their ideas together. If you are on the space, you will see that there are different areas for students or for you to write. And then it says here, what are the next steps? So how can you then implement this by making this a practical activity if this is a real world problem that your students are challenged with? So this also means we have achieved our next objective. We have applied a practical framework to connect inquiry-based learning with critical thinking and collaboration skills. So how do we integrate STEM into our classrooms? So I've created a 3-layer STEM integration model. So the first thing you want to do is you want to connect. So what happens to waste in your school, as an example? You want to create, so we can maybe measure and graph class waste during a specific week. And then you also want to reflect. So how can you reduce this waste at school? So connect, create, and reflect. So we have implemented this in a school that I taught, and you will always start with a problem or a question that students care about. So you are connecting it to their real world and their real life problems. For example, what happens to cafeteria waste in your school? So this gets them thinking. They're not sure what happens to the food after they discard the food. So students can do research and they can start asking questions. The next step of the 3-layer STEM integration model is create. So then we ask students to design or test something to explore. So we can ask them, maybe they can measure and graph the cafeteria waste for a specific week and have this visible in the cafeteria for students to see. And then they reflect. So this is where the learning deepens. How does what we just learned connect to the real world? And when we say, how can you reduce this waste at school? They learn to reflect and do introspection and think about solutions. So during this particular activity, students decided to create buckets with, that's just said, compost. And later on, that food and waste got separated and it got taken to the school garden and used as compost for the school garden. So when we structure lessons to be purposeful, engaging, and relevant to students' lives, we are making sure that it connects to their lives, that it is purposeful, and that it is useful. So why is STEM important in school? Integrated STEM learning increases motivation and achievement in over 80% of classrooms studied worldwide. And studies suggest that across 82% reported improved academic achievement when STEM integration was applied. 78% found increased student motivation and interest in science, and students exposed to integrated STEM development significantly better problem solving and collaboration skills. When we look at everything we have learned up to this point during this webinar, we can definitely see how a STEM activity can encourage engagement in a classroom and encourage participation and also encourage curiosity. So there was a challenge that I posed to one of my students, and this challenge was posed in a social studies classroom, and they used the connect, create, and reflect. Again, this was a cross-curricular activity where she took science skills and then applied it elsewhere. So it shows that learning through STEM makes her skills transferable. So how could ancient civilizations move boats and goods or even food using only natural forces of water and air? So that was the connection they had to make. Thinking about how we are currently moving food and using natural sources to move our own transportation. Then by creating system thinking, understanding interdependence of humans and their environments, and then the reflection, what can we learn from how ancient people used simple STEM ideas to meet their social needs? So we proposed this activity and I will play the video for you.
Okay, so you have to get it out. So what have you tried so far?
I tried picking it up and that didn't work. Don't tell me. Okay.
Okay, and then what else did you try? You tried 2 things.
What else did
You lifted it up?
Oh yeah, I lifted it up.
Yeah? Okay, let's see.
Oh wait. That still gets water out.
Yeah, that still gets water out. So what else? Ooh. Okay, so what can you do to not get the water out?
I got bored.
You got it. Good job. So what made you think of doing that?
Okay, so actually one time I was watching a presentation and they were trying to, it was like, you know those YouTube short videos? They're like, I'll give you $100 if you do this, do that. And then I remembered that in our vocabulary word vibrations, and when we use certain things, it can just lift up some gravity.
Yes, good job. Well done.
So I always smile when I see this happening and how students are connecting what they know to real world things and things that they find interesting, because she mentioned that she saw something similar on YouTube Shorts and she could connect something that is an interest to her science and social studies classrooms. So another way we put STEM in action was through a sustainability challenge that we had at our school. So again, we connected, created, and reflected, and students realized that they were wasting so much plastic through using plastic water bottles, and the caps take longer to decompose. So they collected water bottle caps for 4 weeks and designed a mural. And students reflected on the impact they made by collecting over 22,000 bottle caps and turning it into a talking point and a reminder to be more sustainable. So through this, we only did this in middle school, but it can easily be a whole school challenge. And our students, before this even started, went through data to understand which one takes longer to decompose, the plastic bottle or the bottle caps. And then they collaborated with the art department to create this beautiful mural. So again, the 3-layer STEM integration model. Connect what happens to waste in your school, create, measure, and graph class waste in a week, and reflect. How can you reduce this waste at school? So when we connect, we also make it purposeful. So you want to, for example, in the video, we modeled natural phenomena like whirlpools, storms, and ocean currents. We made it practical. We didn't use any special equipment. It was a tangerine and a container of water. And reflect. So it builds observation, teamwork, and transferable skills. Like I explained, she used this in science, and then she was able to take her skills from what she learned in science into her social studies classroom. So you can easily add this 3-layer STEM integration model to your planning to connect real-world STEM thinking to a lesson that you already teach. So in the chat, just very quickly, how can you connect this to a lesson that you already teach or a subject and grade that you teach? Very quickly in the chat, you can just type there, how are you able to connect this to something that you already teach? This framework is also very useful when you start doing your lesson planning and you are going through Bloom's taxonomy and you want to make sure that you are stretching students and you're giving them opportunities to evaluate, analyze, and create with that higher order thinking skills. So we have achieved our objective where when you take this 3-layer framework, you design simple hands-on investigation using accessible classroom materials. So I want you to very quickly scan this QR code and put this this code in, 832678. It will take you to Ziplet. It will also be put in the chat for you to access through the chat. And this is just a very quick assessment for learning. We're going to look at 2 questions, and I would love for you to respond to the questions. And the questions are, how excited are you to implement STEM in your classroom? And that's an emoji that you respond with. And why is STEM useful in any classroom? So what we have mentioned this multiple times during this session. So why is STEM useful in any classroom? And I can already see that Savannah has responded that she is very excited to implement STEM in her class. And most of you got this answer correct. I'll give a few more seconds. Why is STEM useful in any classroom? So the answer, most of you got correct, is connecting lessons to real-world situations. So I'll give you time. You can still respond to that if you want to. But STEM is more than just a subject. It's a mindset. Small changes can make big shifts. You start with a question, a real-world hook, a hands-on moment, and then a chance to reflect. And that is STEM in a nutshell. If you are able to just give students those opportunities, they will be able to use their critical thinking skills and their 21st century skills to solve some problems. So just to see if we have achieved all of our objectives, we identified opportunities to integrate real-world STEM applications into middle school lessons. We applied a practical framework to connect inquiry-based learning with critical thinking and collaboration skills. We structured lessons to be more purposeful, engaging, and relevant to students' lives. And we designed simple hands-on investigations using accessible classroom materials. Again, the takeaways. So if there's nothing you remember from today's session, please remember these 3 things. STEM integration enhances curiosity and problem solving across all subjects and all topics. Meaningful learning happens when lessons are connected to real-world issues and connected to something students care about. And purposeful, practical, and useful lessons does not require more resources. It just requires intentional design. So some frequently asked questions. What if I don't have many resources or materials? So again, like we said, you don't need advanced tools or materials to teach STEM effectively. In the one video I showed you, we used cardboard and plastic bottles. And in the other video I showed you, we literally used a tangerine and a container full of water. How do I manage STEM activities when class time is limited? When you use the Connect, Create, and Reflect model, you can create a 7 to 10 minute task. The video I showed you with the girl trying to get the tangerine out of the water took less than 5 minutes. Thank you for joining me today. Let's continue to build classrooms where students feel like problem solvers, inventors, and scientists.